Hello and welcome back to the last part of velocity and acceleration lesson. So far we looked at finding the velocity as derivative of position and acceleration as the derivative of velocity or second derivative of position. We learned how to find or derive their equations. We looked at analyzing the motion graphically and connecting it with what the motion looks like in real life. And we also analyze algebraically how to determine whether an object is moving away or towards the starting point or the point of reference. In this section, we are going to analyze whether an object is speeding up or slowing down, and we are going to do this all algebraically. So let's get started. So, how can we tell whether an object is speeding up or slowing down? So for this, I created this very simple investigation made of these 4 graphs. So let's take a closer look at them. Now, these graphs represent the relationship between position and time of some object. Now, in the first 2 graphs, we see that the object is going away from the initial point or point of reference where position is 0. And the values of position are all positive. We also notice that the rate of change of position is positive because it starts at a smaller tangent, right? Or smaller slope of tangent, and the slope increases. So we are going to say that since this object is moving at an increasing speed, it means that the object is speeding up. In the second graph, we have an object that is far from the starting point, which is at 0, 0, or position 0, and is moving towards the starting point. As you can see here, the velocity, which is measured by the slope of the tangent, is all negative and becoming more and more negative. But you can see that the graph is becoming steeper, which means that the object is moving faster. So this is an example of an object that is speeding up, or motion that is speeding up. In the next graph, as you can see here, the slope of the tangent, which is velocity, starts from being very positive to less positive. So velocity is decreasing, which makes this object slow down, okay? So this would be a motion that is slowing down. In the next example, the last one, again, the object starts quite fast, so big negative velocity. And that means the object is moving very fast. It's negative because it's going towards the starting point, but still the object is moving quite fast. But then it slows down because the slope becomes less steep. In this case, we say that the object is slowing down. So what I want us to see from these 2 groups of examples is what it looks like on a graph when an object is speeding up. So you can see the graph is becoming steeper as you read the graph left to right. We always read left to right, just like we read a book. And what it looks like graphically when an object is slowing down, so the graph becomes less steep as we move along the line. So let's take a look at how we can analyze this algebraically. Now we understand that when we talk about acceleration, speeding up or slowing down, we're talking about the rate of change of velocity. So in order to understand how to determine the speeding up or slowing down process algebraically, we need to study the sign of velocity and acceleration. So remember that velocity, according to this first graph in here, is measured by the slope of the tangent, and the slope of the tangent is all positive. In other words, we're going to say that velocity is positive here. On the other hand, though, we say that also we notice that not only velocity is positive because the slope is positive, but it goes from 0 to even a bigger positive, which means that velocity is increasing. So the rate of change of velocity is described by increasing numbers. So the rate of change is positive. In conclusion, we'll say that the product of velocity and acceleration will be a positive number. And the object in this case is speeding up. In the next example, the velocity is described by the rate of change of position, which is measured by the slope of the tangent, negative all the way here. So we'll say that velocity or the rate of change of position is less than 0 or negative. Acceleration, on the other hand, look at it this way. So we have a velocity of 0, negative, more and more and more and more negative. So the rate of change of velocity, which is acceleration, is becoming more and more negative. It's a quantity that is becoming more and more negative. So the rate of change of it is negative as well. So we'll say that the product of velocity and acceleration is described as the product of two negatives. And the product of two negatives is a positive number. So ATVT is positive. In conclusion, we'll say that an object is speeding up if the product ATVT is positive, which on the other hand means that either both velocity and acceleration are positive or both velocity and acceleration are negative, so they must have the same sign. Now let's take a look at the last two graphs. As you've probably guessed, here velocity and acceleration will have opposite signs, but let's analyze it together. So this graph in here, if you drew a tangent, the slope will be positive all the way. That makes the velocity a positive number. Now, if you look at the value of velocity, it starts from being very positive to less positive. That means velocity is decreasing. That means that acceleration is negative because the rate of change of velocity is negative due to the decreasing value of it. That means that the product velocity and acceleration will be the product of a positive with negative. So we'll say that the product of the two will be a negative number. So one last graph. Again, if you look at the slope of the tangent to the position graph, it's negative all the way. That makes velocity negative. On the other hand, we see that from very negative, the slope of the tangent, which is velocity in other words, is becoming less negative, which means that velocity is increasing. So the rate of change is positive, or acceleration is positive. So therefore, we're going to say that acceleration positive, velocity negative will make or will give a negative product. So in conclusion, we'll say that an object is slowing down if AT/VT, so the product is negative. And that happens when velocity and acceleration have opposite signs. So velocity can be positive, but acceleration is negative because velocity is decreasing over time. Or velocity is negative, but then acceleration is positive because velocity is becoming less negative over time. So I hope this makes sense and prepares us well enough to answer this application question. We're going back to our cheetah problem. So I rewrote the same problem. We'll go over it together now to discuss the motion in terms of speeding up or slowing down. So position function is given. T is measured in seconds. S is measured in meters. We have to find the acceleration. I'm going to find it from the beginning in case you haven't seen the previous parts of this lesson. So we start by finding v. That's because acceleration will be the derivative of v, or the second derivative of s. So s prime would equal 3t squared minus 30t and then plus 63. S second will be 6t minus 30. This would represent the acceleration equation. AT equals 6t minus 30. Now, when was acceleration 0? It means that A must be 0. So we have 0 equals 6t minus 30. That makes 6t equal to positive 30, or t equals 5 seconds. So at time equals 5 seconds, acceleration will be 0. Now we have to find the intervals when acceleration is positive and when it's negative. So obviously we can define this very easily because it's a linear relation, but I will create a chart for myself because I like to keep things organized there and add meaning to whatever we are working on. So this would be time equals 0, time equals infinity. And we have only one 0 for acceleration, and that is at 5 seconds. So we'll say that acceleration, which is represented by 6t minus 30, is 0 at 5 seconds. To the left of 5, so between 0 and 5, if you substitute any number in here, you'll get a negative value for acceleration, and here is a positive value. So we'll say that AT will be positive for t between 5 and infinity, hopefully, and AT is negative for time between 0 and 5 seconds. Now we have to find the intervals when cheetah is speeding up and the intervals when cheetah is slowing down. So in order to analyze this, we are going to build a chart where we analyze the sign of velocity and acceleration. We know that an object is speeding up when ATVT equals a positive, so the product is positive, and it's slowing down when ATVT is negative. So in order to be able to make this judgment, then we will have to know when AT is 0, when it's positive, when it's negative, and when VT is 0, positive or negative. So we are going to build the chart, long line that represents the values of t. And here goes time of 0 seconds to infinity. Now, we know that A is 0 at 5. And we know that V is 0 at the times, and we're going to borrow the information here from our first part of this problem. So we said that velocity is 0 at the times 3 and 7 seconds. So on the number line, we'll have to place the numbers 3, 5, and 7 in order. Draw a vertical line here and place the sign of VT here, and then the sign of AT here. That looks a little awkward. Here. Draw another line, and here we're going to write or give information about the sign of AT-VT. And last but not least, we have to make a judgment whether the object is slowing down or speeding up. So that's the description of the motion. So recall that at 3 and 7, velocity was 0. So velocity is 0 at time equals 3 and time equals 7 seconds. Acceleration is 0 at 5 seconds. So the product will be 0 at 3, 5, and 7, the product of these two. I will start off with velocity. If you remember the velocity equation that we obtained from the first part of the problem. Here is 3t squared minus 30t plus 63. Minus 30t plus 63. And if you remember, then we factored this into 3t minus 3 and then t minus 7. Okay? And we said that between 3 and 7, velocity was negative. And positive on the sides. Acceleration, on the other hand, is negative to the left of 5, positive to the right of it. So that means that the product of the two will be negative, positive, negative, positive. So in conclusion, then, we'll say that the object is slowing down between 0 and 3 seconds, slowing down between 5 and 7 seconds, speeding up between 3 and 5 seconds, and also speeding up between 7 and infinity seconds. Okay. All right. So here and here, and here it is, the slowing down time interval. Okay. So I hope this all made sense, and I hope you enjoyed the lesson. Thank you for listening.